right. Hello, everyone, and welcome to a very special digital manufacturing talk. My name is Tyler Fenhouse. I'm the marketing manager for Symphony AI Industrial, and we've got a great informational talk today focusing on the world's first industrial LLM. As you may know, Symphony AI Industrial is a leader in industrial AI solutions in digital manufacturing, plant performance optimization, and connected worker. Symphony AI Industrial is a Symphony AI vertical. There are several Symphony AI verticals. You can see them there on your screen now. And we are one of the largest, if not the largest, enterprise AI companies with more than 1,600 customers and 3,000 employees. All right. And as well as questions, I forgot to mention, be on the lookout for poll questions that Srinivas and Sudhanshu will be asking you throughout the presentation, which will kind of guide the presentation. Okay, I know you didn't come to hear me ramble, so I'm going to hand it off to Srinivas, and we're going to get this started. Srinivas, take it away.
Thank you so much, Taylor. Thank you, everyone, for joining this meeting. This is a very, very significant webinar for Symphony AI Industrial. Of course, we have been running the webinars for quite a bit of time, and we do so every two to 3 weeks on an average, but this one is a groundbreaking webinar for us. As you know, before we get deep into the topics, I got with me Sudhanshu Kashyap. He's our distinguished engineer. He has been significantly responsible along with our technical team and the product management team to bring in a key set of technologies into the market, leveraging the generative AI capabilities that we believe can bring in significant differentiation for our manufacturing customers when they adopt it on their shop floor. Okay, so I introduce you to Sudhanshu. You'll be hearing from him for the most part when we do a deeper dive into what our technology is and how we believe it can really transform our partners in enabling our customers use the technology and draw differentiation, as well as our customers themselves when they start using these products. Okay, so before we jump into a deeper dive, I would want to lay down the agenda. Like I said, Symphony AI Industrial, it's all about manufacturing, maintenance, and reliability is our key focus. We look at manufacturing shop floor as a 3 legs to the stool: the quality, the manufacturing side of it, which includes production, and then the maintenance and reliability, where product capabilities that are being offered in that space. Now, focusing on the LLM, which is what we is the key element of this conversation. As you all know, the whole world is traveling towards generative AI adoption across various verticals. And what we have done is we have taken a very significantly transformative path. There are a whole bunch of generative AI capabilities through LLMs of various kinds. Mostly, they're all general intelligence-driven LLMs. However, with the ability of our technology team, as well as the data that we have been able to anonymize and source with us for a long periods of time, 50 plus years of company ecosystem that we had, we really took the path of building in an LLM that's highly focused and domain expertise driven for the manufacturing space. So the details will come in when Sudhanshu gets in there. So we made a recent announcement. A lot of information has been published out there. As you can see out there in the Yahoo publishes happen. We have included a lot of details on our website as well. So everything about the industrial LLM, you should be able to learn about it. But in this particular webinar, we'll cover 4 key topics. One is, first, we want to introduce what an LLM is so that we level set that understanding among the folks. But then we want to quickly deep dive into what a domain optimized or domain grounded LLM in the industrial space is. That's what we're bringing into the market. Then Sudhanshu will go through the actual live demo and then show you how you can enroll into getting access to our industrial LLM and build your own applications, or use that as a way to really enable your customers to start building some products around it. The last but not the least is we want to talk about the ecosystem around the LLM. LLM alone would not solve all the problems in the manufacturing space. It really requires a mechanism to take the data, translate that into knowledge and intelligence. So we'll talk about other key product areas that we're bringing in and the announcements that are yet to come. Next slide, Sudhanshu. So Taylor talked about it. I'll quickly breeze through it. I'll not belabor the point. We are part of Symphony AI, which is a large company. Our motto is to really drive AI-enabled SaaS solutions into the enterprise space. As an industrial, which is one of the 4 legs of the stool for Symphony AI, we are playing in quite a few significant industries within the manufacturing space. And thanks to our product ecosystem, we are not just about LLM. We have a key set of products that we have been selling in the market for several years to decades. Thanks to our work, our success with our customers, we have been recognized by quite a few, recognized analysts out in the market. Sudhanshu, next one. So one other thing that's really significant for us is when we decided to go and bring in this world's first industrial LLM, as we're calling it, because there's not one that's built with domain-grounded expertise that's focused towards manufacturing, maintenance, and reliability. As we did this, we really partnered along with Microsoft, knowing that it's just one thing about the technology, but there's another thing about bringing the technology for folks like our partners and customers to use it as an API or other mechanism to start building products around it for value add. We really need a partner of the scale and caliber of Microsoft. Thanks to Microsoft and the key folks in there, we have been able to bring this product out into the market by really standing on their shoulders. Sudhanshu, the next one. All right, so before I hand it over to Sudhanshu, who will really drive the meat of the conversation around LLM and walk you through the whole hands-on, one other thing I want to draw is, of course, this one webinar is not going to give you any more than a teaser and an interest to really access the product through API or other means or chatbot. What is also important is to really see how this can enable you as a customer or a partner who is working with the customer to use this in a product ecosystem. So we have kicked off a roadshow set of events in various key cities across the globe. We will be having one in Dubai next week, but the one that's coming in US is in Minnesota the week after. November 30th is what we're targeting. So if you want to really do a deeper dive, talk to us, really say how this can draw the value, because like I said, LLM has the co-pilots around it, the knowledge graph, and the whole ecosystem of maintenance and reliability, manufacturing, connected worker, product ecosystem that interplay with this LLM. We are really bringing in transformative technology. So if you really are interested to do a deeper dive with us, of course, you can reach out to us virtually and we can figure out ways to communicate with you. But if you are in town around Minneapolis, November 30th, we give you an open invitation to come and join us. We will have a follow-up event late of January in Houston, but then we are having one in Dubai next week, and there'll be a few more events in Europe as well. Okay, so make sure this is a call to action. If you really want to come in, absolutely, you're welcome. All right, with that being said, Sudhanshu, you want to give us a flavor of Industrial LLM?
Okay, thanks, Srinivas. And before we get started with Industrial LLM, Tyler, let's do this first poll question for audience.
All right, and I did just launch it. You should see it up there on your screen. All you need to do is click the radio button to vote. It might also be in the chat, so go ahead and click to vote. Is your organization actively using or plan to use LLMs? Already using, plan to use within 6 months, or no plans as of now? Go ahead and get those in, and it looks like a little under half of you have voted, so go ahead and vote. I'll leave it open a little longer so we can get kind of a feel for the room moving forward. Couple more seconds. Get those in. All right, let's take a look. And all right, Sudhanshu, so it looks like 43% are already using, 26% plan to use within 6 months, and 31% no plans as of now. Back to you.
Yeah, that's great news. So majority of you are already using or plan to use large language models. So and if you are not using, we'll start with some fundamentals and basics. What are LLMs? So we'll go about it before we jump into our industrial LLM and what are the salient features of industrial LLM from Symphony Industrial. So the first question comes: what are the LLMs? And as definition goes, these large language models are foundational models, and also kind of artificial intelligence models, which are designed to understand, generate, summarize, translate natural languages, human languages, multiple human languages. So we see many of these terminologies here. And now if you want to look at some examples, you already might be aware, the GPT is there, Llama, Falcon, Bard. So all these kind of models, what we hear and see, these are large language model, or we also call them a foundational model. So certain terminology is what we are seeing here, like foundational model. So let's understand what really that means. And the term foundation, as it signifies, it is base of the building block, right? So that's what here foundation model also means. So it is being trained on extensive amount of data, and it has a vast amount of general knowledge, so it could be adapted in variety of tasks and applications. So you could take a foundation model and you could modify it, you could adapt it to a certain specialized task. So that's why these kind of models are referred as foundational models. So other features, what you see here, that large language models. So why it is called large model? Because these models are really large. So they some of these models have hundreds of billions of parameters, and to run these models or train these models, you need a very high amount of compute. So you need GPUs or a series of GPUs to train these models and also run these models. So that's why these models are called large models. If you want to understand a bit more about architecture, I will not go in very depth, but these are transformer-based deep learning models. So you must be aware about neural networks and deep learning models. So in this similar kind of models, but the core of these models are transformer based deep learning models, and quite complex mathematics goes behind it, which is we are not going to cover in today's session. And then, of course, the most important aspect here is the application. So where these large language models are being used, and you could see we are already using chatbots. So I think most of you have used the OpenAI chat GPT, where you could ask questions and you could get answers, and you could also generate some very cool things. So that kind of chat applications, it can be used. And co-pilots, we'll talk about some co-pilots we are also developing for our organization, where it could look into your data and information and make sense out of it. You can collate multiple sources of information and give you answer to one of your question in a very summarized, nice way. So those are another good applications of large language models. Content generation. So you want to write something, you want to generate some banner, or you want to do some create some advertisement. Those kind of content could be generated by these models. Of course, you might have heard about GitHub Copilot, that is code generation, that uses a large language model in the backend. And of course, if you want to use it, writing assistance and teaching assistance, all those kind of assistance these models could do, because they have a very vast amount of general knowledge and information on which they are trained on. So that's why they could be used to variety of tasks, and that's why we call them the foundational model or fundamental models. So then the question comes, we talked about industrial LLM. So what is the industrial LLM we are talking about, and why we are developing industrial LLM, where when we have many of these generic models already available into market? So in next few slides, we'll answer these questions. So let's see why in the SymphonyAI industrial LLM is different from a generic LLM. So we have fine-tuned foundational model for industrial applications, and that's came out as an industrial LLM. So now the question comes: what is fine-tuning? So let's understand with one simple analogy here. So suppose there is a person, and that person has general knowledge of world. He knows about mathematics, he knows about physics, so he has all the fundamental. So now if we decide that this person has to be taught quantum physics in depth, so since he already have some fundamentals of mathematics and physics, and other aspects which is required to learn quantum physics. This person could be taught quantum physics, and once he was learning in depth, he becomes expert in quantum physics, and he could answer very in-depth questions from quantum physics. So that's exactly fine tuning is. And when we say a person with general knowledge of world and basic fundamentals, and that's what we are talking about, a foundational model, which is a general purpose model. And then we give more information to that model from a specific domain, and that model becomes very specialized in that particular domain. So that's how fine tuning works in real case. So let's look into how we did it for industrial LLM. So we have taken open source model Llama. You all be knowing about Llama 2 model, which is a foundation model, and then it is trained on very large amount of data. And we fed it to industrial data and fine-tuned it on industrial data. So the industrial data, the way we input to this model, there's an input. For example, you see that in condition monitoring, you take vibration spectra, and that gives a health of your rotating equipment and machine. So we analyze that spectra and get an output like, okay, what is cause, what is going with my machine, and then what I should do about it, a kind of recommendation. So these input-output kind of data, if you already have with your previous analysis, so you could give this kind of data to a large language model and fine-tune it so it could learn more about condition monitoring and vibration data and how to do causes recommendation, identification of the problem from a rotating machine. So now this model becomes much more a specialized model and becomes an industrial LLM. So it has the world knowledge, what it used to have as a foundational model. But since we have provided additional data, which was very curated, very domain specific, and then now this model becomes much more efficient answering questions about that particular domain, which this generic model or foundational model was not. So it might have some knowledge about vibration or condition monitoring, but it might not be very specialized or expert on that. But this model becomes expert on that particular domain. So that's how the fine tuning works, and that's how we fine tune a generic model to a foundational model to create a industrial LLM. So now next question comes that what kind of industrial data we use for this fine tuning, and we'll cover in the next few slides. So when it comes to industrial data, and we all know that data comes from different sources, it's the CMMS systems, ERPs, then we have operational data, which comes from historian, MES, SCADA, and of course we have engineering data, SOPs, and manuals. So a lot of information available through plant. So all these data can go through a kind of a knowledge fabric or data contextualization, where it could be enriched with a context, and then it could be fed to these kind of foundational models to have very specialized industrial LLM, which could answer question for a specific industrial domain. So that's how we plan to train and fine tune our industrial LLM model. So in the first iterations, just to give you some idea, we have 1.2 billion tokens. So tokens is a terminology what we use for. You can say it's a kind of one token is equivalent to around simple one word in layman terms. So that's the amount of data we have fed for fine tuning these models, industrial LLM. And that includes almost 500,000 machine tests covering 80,000 assets. And if you look at number of data points, what is being fed is 3 trillion data points overall. So as you could see, this is very, very large amount of data which has been fed to this model to make it specialized for industrial domain. So now we'll talk specific about Industrial LLM version
Sudhanshu,
1.0.
Sudhanshu, if you don't mind, there's a question that came up which probably need to be addressed in the context of that slide. If you go back to that slide for just a moment. We want to be very clear, right? The focus is that blue box, the industrial LLM, that is built based on the data that is not specific for any customer. So there is no violation of the data privacy or any specific customer data or whatnot. Over time, we have anonymized the data. We created a spectral format of the data, mostly on the reliability and maintenance side of the data. And we have used that to fine tune that model to be that much more effective for being the specialized model in the specific industrial set of activities for asset health, asset upkeep, and so on areas in that context. Now, the white boxes that you're seeing are the augmentation layers of that industrial LLM that we're talking about in this context. Those white boxes tend to be customer specific. If a customer says, let me bring that industrial LLM into my ecosystem, of course, the LLM alone would not solve all the problems. It may know, for example, what should it deduce out of the asset behavior, or what is the optimal way to really assess whether you should do a maintenance, a repair, or an overhaul. So really draw that kind of a expert response back, but it would not know anything specific around the customer data, like the work orders, the lifetime of the asset, how long has the asset been running, what kind of manufacturing process that it's running. That information need to be brought in and augmented for the best outcome. That is coming out of the customer specific data sources, and they tend to be within the customer's four walls and where they are. That will not be brought into the LLM itself to be additionally fine-tuned. So I want to be very, very clear. There is no real cross-contamination or any level of customer data being brought into the LLM itself. So Sudhanshu, please go ahead.
Thanks, Srinivas, for clarifying it. And in later this presentation, Srinivas will cover some of aspect how we use this knowledge fabric and all this data from a customer domain itself, along with industrial LLM and predictive models to give more insights with plant operations. So and that we call it co-pilot. So we'll cover that later in this presentation. Thanks, Srinivas. Okay, so as Srinivas was mentioning on the previous slide, this industrial LLM, we have taken asset metadata and vibration spectral features from vibration data, and then contextualize causes and recommendation. And these data we had for almost 20 years of data, which was completely anonymized and being used to fine-tune the Llama 2 model, which is become an industrial LLM model. So if you look at the salient features here, so these models are done on large proprietary industrial database. And as I mentioned earlier, you need a large amount of hardware resources, GPUs to fine-tune these models. And responses, what we have here, contextualized causes recommendation is always vetted by a human analyst. So look into the results. And the data we also had, there was spectral features and metadata, and then we had human vetted outputs, which we used to train these models. And after in whole this fine-tuning process, also we involved human analysts to look into the results and verify how it is coming out. And finally, it does support human-style queries on topics related with rotating equipment, vibration-based diagnostics, and reliability. So you can go and ask a question to this industrial LLM, and it could give you an answer in form of causes and recommendations. So we'll very soon we'll see a demo how this whole thing works. And we plan to augment it in next iterations of industrial LLM, adding some process data to it, that is sensors data, pressure, temperature, flows, also lot many rules, manuals, data sheets, and other kind of oil report, logs, and failure mode analysis, which we have. So we are in process of gathering all this data together, and it will be these models will be fine-tuned further to make it better and give more meaningful results, insightful and interactive responses in future. So now we come to a demo part where this industrial where I'm gonna show you how this industrial LLM really works, and this is the URL. So you could, if you go to this industrial LLM.symphonyindustrial.ai, you should be able to do a sign up here, and make sure you sign up using your organizational email ID. We will not allow personal email IDs as of now. And once you sign up, you will get email verification. And once you do your email verification, our backend team will look into your request, and they will approve it. And once approved, again, you will get email request that your access to industrial LLM is approved. And then after that, you could go and explore, ask questions to this LLM. Also, we have APIs, which you could exercise if you want to make an API call and pass your questions and get your answers, and you want to integrate this into your system. So this API allows you, and this kind of chat interface also we have, where you could ask a question and get the answers. So let's jump into the demo, where I will show you more about it and how it works. Srinivas, my browser is visible now?
Yes.
Okay, great. So now I'm at this site. You could see industrial LLM.symphonyindustrial.ai. And at this screen, you see two options, sign up and sign in. So first time if you are coming here, you need to go to sign up, and it will ask to fill you some information. So if I click, you might have this kind of form where you need to fill all this information and do a request. And as I mentioned previously, there will be some email verification and then approval. After that, you'll be able to sign in and access the next step what I'm going to show you. So I'm going to sign in now, and it will ask for email ID and password. And here I'll get into the industrial LLM inside. Now you could see there are tabs on the top, and you could see API, LLM chat, help, and other tabs here. I'll go through some of them. So let's start with LLM chat, and this is the chat interface what we have. And you say there's already a sample query here, and it is saying that in a coal-fired power plant, my asset of interest is a centrifugal boiler feed pump connected with flexible coupling to an AC motor with a certain speed, and then I recorded following vibration spectra features. So the certain features we are giving here. Now location 2 is motor bearing inboard, location 3 is pump bearing inboard. What could be the most likely issues and recommendations? So I'm going to ask this question. So just now I have submitted this sample question, and so the way whole the backend works. So these questions are getting submitted to a backend model, industrial model, which is running on a GPU, and then we get diagnostics and answers. So you see now that we have some answers here. So diagnostics are angular misalignment, and also it's giving some severity. So it doesn't looks very severe. It's medium severity. Maybe there could be a low severity parallel misalignment or a motor bearing wear, and recommendations that inspect coupling and check shaft alignment. So so this kind of investigation you can do on your rotating equipment. So if you have vibration spectra, and you could provide information about your asset, and then give some features of your spectra, and ask a question about what could be problem, how does it look, and then it will analyze your spectrum and give you diagnostics like you are seeing below. You could also ask some questions which are again related with the industrial domain only. So for example, this is a centrifugal centrifugal boiler feed pump, and you want to know what is angular misalignment. So I'm going to just put a question: what is angular misalignment on centrifugal boiler feed pump? So this question is not only about condition monitoring, but it's still an industrial question where I want to know more about angular misalignment on centrifugal boiler feed pump, and then it goes and give you an answer that what does it really mean. So you could ask these kind of questions, but if you try anything out of industrial domain, it probably will not gonna answer, because this model is confined to answer industrial questions only, and mostly on rotating equipment condition monitoring domain. So very specialized area on which this is fine-tuned to work, and we limit it to work in that domain and give you very specific, very good and real answers on those topics. So now I will little bit go to the API page, and as earlier I have mentioned that here you could chat, you could put your questions and you could get your answers. But suppose you want to integrate with your systems, you are building some application where you get the vibration kind of a spectra, and then you want to automatically make an API call and get these kind of diagnostics and recommendations. So for that purpose, we also provide API support, and this is how you will make your API call. You see there is a post request, and then you need to provide a subscription key, and this subscription key would be available into your profile page here. So if you go to your profile page, and then your once your subscription is approved, you'll be able to see a primary and secondary key, and that you could utilize to any one of it. So you could use either primary or secondary, any one of it, to access this API call. So you could supply that here in headers of call, and finally you need to give your inputs like this. So input, that is your question. And then you could also pass an optional parameter where you would how big answer you want. So for example, say you want 200 tokens as output. So if you want a bigger, you could supply that as well. So this is how you could use this particular API, and clicking on try it allows you to exercise it from here itself. And once your subscription is on, your authorization already being populated here, and then there is a simple query what you see, and if I click on send, it is making this API call with all these inputs and all the subscription key what I have here, and it will get a response in some time. So now see, so this was success, and then you could get your answers in this format. So you could pass it, and then you could display it to your application, or you want to further use it for any other purpose, you could do that. So this is how you should be able to exercise APIs here. Now I'll a little bit go on the help page and explain that how should you form your queries such that you could get best answers from these models. So the prompt is very important. So the way you ask your question, and if you do that well, your answers will be more reliable and more accurate. So I'll very briefly explain that if you are trying to analyze your equipment with a condition monitoring data, that is vibration spectra, what information need to supply. And there are three critical parts. One is machine information, and machine information is about your asset information. So you could say, like, I have an AC motor with 34 rotor bars, all ball bearing, and no free and cooling fan connected with flexible coupling to a rotary sliding vane PAM. So basically you're giving kind of a very brief description what kind of equipment or asset you have. And once you give that machine information, second is more about your vibration spectra features. And vibration spectra features, the required information is vibration spectrum peak values. So it is recommended to put into unit inches per second. And then next is if you have some exceedances, so you know already what is your baseline values, and if that information is available, you could give that how much higher it is from that baseline value. So this is optional, but providing this information enriches the data and gets better result. And also these locations where these measurements have happened, like location 2 is motor drive and location 3 is pump inboard. So all those kind of information, so model could understand where these measurements have happened, and a direction of measurements, whether it's axial, horizontal, vertical. So all those kind of information from your spectral features you could extract and put into the second piece, that is vibration spectra feature. And a third one the model would expect is machine speeds. And machine speed, as you know, what RPM the machine is running, and it's like a rated RPM of the machine, so you could give that information as well. So these are the required information, and if you supply all of it, you'll get your very nice, good answers. But if you supply few, it might infer with given information, but also it would say that probably I didn't get full information, and your answers are answers that this is what I could assess from given information. So the confidence of those results might be low, but if you give full information, you'll get good results. So this is about, and these are some sample queries you could see. You could even go and provide much more information if you have, and you could give less information, as we saw in that queries, which I run some time back. And the answers from this LLM would be diagnostics with severity. So we'll see that what kind of problems. So we saw angular misalignment problem when we run our previous query on the chat, and also you'll see what kind of recommendations we should do. And occasionally we will have also remarks, and that is more like a human analyst remark, which we have fed into these models to understand more about, beside diagnostic and recommendations, it gives observations more like a human analyst, that okay, what additional things you can do to improve your asset, or what additional data you should expect from there, and what kind of checks you should perform. So those kind of remarks also comes, not always, but sometime you might see if you supply enough information. And I talked about using the APIs, and using APIs, you could either use a REST kind of framework where you can make a Python code, and this is some example given. Also, you could use the curl kind of commands to run those APIs. So all this information required to access and use the large language model is available here. And again, I will highlight that in the profile page, you'll have your API subscription key, which we could use to make the API calls. So that's it about a demo of industrial LLM. And now I will give back to Srinivas to talk about knowledge graph and copilots. So over to you, Srinivas.
Thanks, Sudhanshu. Thank you so much. Before we jump into the knowledge graph, I saw a couple of questions coming in. I addressed most of them, but I kept a couple for making it more of an audible response. So Sudhanshu, one of the questions that was asked is, I'll generalize it. What if the Copilot is not giving you the exact accurate response back for the technician to take an action, right? For example, the spindle is moving 1x, 2x, whether there's a corrosion or not, and vibration is in the risk area or not. I'm not expert in that. I'm not an expert in that space, but nonetheless, the question is, what if the response is not at the level that is accurate? I'll try to answer the question, and you can add the flavor to it, Sudhanshu. What we did, once again, this is a large language model. This is an AI model. It's possible that some of the times it may not give you the most optimal response, right? However, what we did with the industrial or domain grounded LLM is, number one, we avoided the responses to be way too of an outlier, number one, right? By really containing it to be smart in a specialized space than to be way too generic and broad. The second thing is we are introducing the concept of explainability, which really draws the idea of almost as a connecting the dots as to how the LLM came to that conclusion and what data source has it used to provide that feedback. That enables the end user to say, okay, fine, in this case, it's not exactly the optimal response, but I understand where you're getting it from, so I'm more convinced with what the LLM is saying. But then we provide an ability for the end user to provide the response back for the LLM to be better off the next time around. Okay. The third aspect of it is to introduce the version 1 itself. What we have done is we have done a blind test, right? We got these reports that come out of the LLM, presented it to the expert analysts, and have them rate the reports: poor, good, excellent, some kind of a gradient to say, is this report at the class of an expert analyst? So we got a very good percentage of feedback where most of the outcomes were within the ballpark of something we believe can be rolled up in a test bed and a implementation at the shop floor level. So that's the summary of that. Sudhanshu, anything to add on that?
Yeah, I think the most important piece here that responses are validated by human analysts. So we have extensively tested it, but yes, means there might be possibility sometime you may not get a complete answer. And it also depends how much data you supply to it. So if you give it enough data and information, your answers will be more accurate. But still, there might be some cases where you may not get exactly what you want. But majority of times you will have a good answer, because we have fine-tuned using human feedback and an analyst being in loop. So it's not completely unsupervised. So
yep.
Yeah.
Okay, so let's go to the knowledge graph one quickly, Sudhanshu. As I go through it, I'll try to address the other set of questions as well, and then we can go to Q&A. So once again, as Sudhanshu has mentioned, and I have mentioned as well, LLM is one of the key components of AI-enabled knowledge, insight, and wisdom, or intelligence, how you put it, brought into the shop floor, right? That is sitting on top of the data and really delivering that value add for you. But you got to have an ecosystem of capabilities to really get the significant value for that end user as a plant manager, reliability engineer, maintenance technician, or so on. So once again, the LLM in itself is one piece, critical component, but it should be augmented with your own data sources, because sometimes, as the examples were given, maybe you don't want to rely on the LLM to give you the insight. The insight may be coming directly from the system of record that's sitting in the back end, a CMMS system or an MES system or an EAM system like the IBM Maximo, right? Because you're purely dependent on the data and you want to get the exact work order number and exactly what happened at that work order 3 months ago. So their LLM doesn't really play any role outside of putting it in a natural language. So this API that Sudhanshu talked about enables you to not just talk to the LLM, but over time, as we start releasing the later versions, you can connect directly to the systems of record using the, function calling mechanism to really go, and system is smart enough to identify which source of data need to be pulled together and brought in to the end user. Okay, so decision making is not always on the LLM side. The second part of it is the predictive models, right? AI, generative AI is one component. There's the other piece, the vision-based models or regression models or classification models, or any kind of a predictive side of it. Well, if you're enabling the LLM itself to do all of these, in other words, having the APIs to connect to those specific AI models, great. Otherwise, generative AI LLM on itself is not a predictive model. So we will be enabling the capabilities, which we have been delivering to our customers for a couple of years, several years now, where the LLM can start leveraging the other AI models, which were built for specific purpose, for classifying the data or predicting what the next set of variables would be and so on. So the LLM will redirect the questions to the specific sources of the data or to the pre-trained models and to get the data, basically paraphrase it, bring it to the end user. So don't treat this as a standalone, but something that will build this kind of an API-based ecosystem to tap into your data sources as well as AI models that we offer. Okay, so that brings up the knowledge graph. We do understand that the data is the most important element. So we are, you will start seeing a whole lot of announcements coming in the next set of months from us. It's not like we're sitting on top LLM, but we're really ignoring the whole idea of taking your data and contextualizing the data and drawing that knowledge graph for you. The unified namespace or ISA 95 compliant or any industrial standard you may be following. So we are introducing a set of tools to really connect your whole digital journey. That is, if you have the data source, either your historian or your assets, how do we bring it together? How can we really draw that the sense of a data structure, then put an optimal knowledge graph structure that can be dynamically optimized for the needs you want. And then how can this knowledge graph then go augment your industrial LLM alongside with the other predictive AI models? So together that will draw the overall value. Sudhanshu, please go ahead. Next slide. So another announcement that we made, I think the beginning of this week, is around copilots. As Sudhanshu said, our industrial LLM, the call to action here is, if you are a partner, want to build solutions, give it to your customers, of course, you can enable, submit your request, and we can give you the API, and you can start building it. But then the LLM is one aspect. We are bringing our own copilots. Our product ecosystem, as you can check on our website, covers asset performance management, manufacturing operations management, and connected worker. And then we have this layer of advanced industrial analytics. For these products, which we have already been selling in the market, we are enabling our copilots that use industrial LLM as the backend as one of the pieces. It also leverages other tools and technologies. But then we are bringing in copilots. The way we package the copilots is that 3 copilots: connected worker, manufacturing operations management, and the asset performance management. But nonetheless, the way we packaged it is it's targeted towards the end user personas in your shop floor. Sudhanshu, please. Yeah, so this is where we have, for more information, obviously you can look at our website, you can reach out to us, we can do demonstrations and really can show how either you have your own data source, you want to have a copilot sit on top of it and draw immediate insights for the end users, or look at our products and how they're embedded with this AI capability.